So you guys remember that this is just a geometric series?
No,
where the common ratio is x. So when you expand it, excuse me, just 1 second. Hello? Hi. You're kidding me. All right. Lil Hopital, there's some people doing some bad calculus. Go take care of it, please.
I'm on it.
All right.
Yo, 2 Chainz. It's not good, man. I challenge you to a rap battle. Right now. Let's go.
Look, if you had one shot to solve any problem you ever wanted, would you capture it or just let it slip? Yo, his work is messy. For this task, he's not ready. Notation is so bad, looks like a 6-year-old was writing. Thinks he knows it, he thinks he understands it. He calls himself 2 Chaniz Rule, but keeps on forgetting. Formulas go in one ear and then come straight out. Make the teacher so mad that she wants to shout. You should be freaking now, your future's bleak. And now, I'ma use my calc knowledge to smash you down. Snap back to trigonometry, back to geometry, back to algebra, the class in which you should be. My name's Lil Hopital, and I'm the best MC. I can do complex series, but they seem easy to me. They got the bad calculus, but I just can't accept this. How long you going to jail? That limit does not exist. I'm the crusader for good mathematics. Y'all better listen up right now to Lil Hopital. Now check it.
People call me 2 Chaniz Rule, not Andrew Chain. I write clear and neat, more like Sean Wayne. Yeah, I understand it, I think I know what's about. Miss Lucas not gonna mad, she's not gonna shout. You on the other hand just don't understand. Your calc teacher will slap you with the back of her hand. My deriv's so clean, you should drive like me, but you integrate like an idiot, forgetting your plus C. I'm the gangster of calculus, that's why they call me 2 Chaniz Rule. You're called Lil Hopital, cause you can only drive in school. Your test scores are so low they're not even positive. It's probably because you can't even do partial derivative.
Calculus knowledge you seek.
Find a great calculus master you must.
I must go find the great calculus masters underneath the high school.
So let's say dx. Someone told me that you know the secret of the partial derivatives. Can you teach me?
Young Padawan, you have come to the right place.
Now, I shall take you on a magical journey where the language is only calculus.
Alright, Lil Hopital, I'm going to teach you how to do the partial derivative. You're a smart kid, and I think you took calculus before, so you should know how to find derivative with only one variable. Let's just say x over here of x squared. If you find the derivative of this, what would that be? You probably should know this already, and it's got to be 2x. And if you plug in a point for x, then you know what the derivative is. But the question is, how are you going to find a derivative if there's more than one variable? How are you going to find that? Because the interesting thing is that the x can increase or decrease at a different rate than y. So there are infinite many derivatives you can find if there's more than one variable. So that is why to find the derivative of a function that has more than one variable, we're going to use x and y for our case, and let's just say the function is equal to x squared times y cubed. We are going to keep one of these variables constant for one time to find derivative and to find a derivative with respect to that only one variable and hold the other constant. So let me tell you what I'm talking about. So first let's just rewrite the function and keep y as a constant. So we'll just do this. X, y. And if you want to find a derivative of this, and if we hold y constant, what will that give us? We have to derive x squared, which is just going to be 2x. But since y cubed is constant, we just leave it on there. So this is a partial derivative with respect to x, which means we are holding a y constant. And if you want to find the partial derivative with respect to y, for our particular function, we will have to keep x squared constant, and we will have to derive y cubed, which will give us 3y squared. Now for the partial derivatives, there are many different ways to notate it. One of the examples is this weird cookie symbol, which is not d. It's different from d, which is going to be this weird symbol. And since we're deriving with respect to y, we're going to put y on the bottom over here. We're going to write the function of x and y. Another way to write this is just to put the variable on the top. We'll let this whole equation equal to x. And if you do that, we can just write the x on the top like this, as so. And this will give us the notation for partial derivatives. Or another way you can write this is write a big D, but we had to write a little superscript over here. Since we're doing respect to y, we're going to put y over here and put our function over here. And for the x variable, we just have to switch the symbols up. So instead of y, we put x over here. The same thing, instead of y, we put x on the top. Oh shoot. So you don't want to do that. You don't want to write d. It's not d. And also big D x. So this is a general idea of how to do a partial derivative. Alright, so this is a derivative with respect to x, which means we hold the y constant. This is a derivative with respect to y, which means we hold the x constant. Now the thing about this is, what we did was we basically tried to find the derivative or the slope of a 3D object. Just imagine a sphere and there's a point. And if you look at the 3D object and try to pick a point and try to find the slope, you will have no idea which slope is the right slope that you want to get, because you don't know what the direction is going to be. So let's say there's a sphere and you take this direction, like going to this direction. The derivative is going to be different than a slope that is going to another direction. So the reason why we hold one of the variables constant is just to take a direction. And then if we do that, we limit ourselves to a tangent plane. instead of a linear line as a slope, it's basically going to be a whole surface or a whole tangent plane that's going to cover the object, which is going to be the derivative of the original equation with 3 variables, for at least in our example. And Sensei Oleg is going to be the one that's going to be teaching us all about the tangent planes.
Goodbye, someone. Now that you know the ways of the partial derivative, now you must master the application. I've already given you the information to find the wise Riemann and Weep. He lies in these tunnels. Now, it's up to you to find him. Go!
Thank you, Master.
Are you Riemann and Weep?
I am. I know what you seek. You seek to destroy your enemies. But you cannot do that on partial derivatives alone. What you need are tangent planes. Come here, young one. I shall show you the application of tangent plane, so you may fulfill your quest.
Ross, now you know how to do partial derivatives, but you're not going to win your rap battle unless you know how to use them. This is tangent planes. I'm going to teach you what to do with your partial derivatives. Cool? Okay. Now we're going to start with the general formula for any plane. We have A times the quantity x minus x naught plus B times the quantity y minus y naught plus C times the quantity z minus z naught equals 0. That's a general equation for any plane, whether you're going to be finding partial derivatives or tangent planes. Now, in order to get this to suit our purposes, we need to modify this equation a little bit. We're going to swing that C on over with the z minus z naught. So then we're going to get A x minus x naught plus B minus B naught equals C over z minus z naught. Now, if we divide both sides by C, I'm going to change this equation up a little bit. Then we're going to be left with z minus z naught equals negative A over C times x minus x naught plus B minus y naught. Now this is where you got to go a little bit abstract thinking over C. Now, if you take the negative A over C and the negative B over C, you're going to combine those into 2 other variables, A and B. Now, when you're taking partial derivatives, you take one variable at a time and you hold the other one constant. So we're going to do the same thing. We're going to erase this. So we're going to start with x's. We get z minus z naught equals A x minus x naught. Now this right here is a formula we all know. That's the equation of a line. You got your 2 variables, and then you got your slope. So what we know is A is going to be the slope. And when we get to find the partial derivative with respect to x, that's also going to be the slope. So basically, we know that this A is going to be the partial derivative. So that's where this all comes into play. Now if you do the same thing with the y's, you hold it constant for B, you can get the same thing. You're going to have B equals the partial derivative with respect. Okay, Lil Hopital, listen up. We're going to review what our variables are here. We got 2 equations. We have a differential equation, and we have the equation of a tangent plane. Now in our equation for the tangent plane, we got z naught, that's the initial z. We have A, which is the slope of the differential equation when we hold y constant, which is also going to be the partial derivative with respect to x, right here. B is going to be the slope when we hold x constant, and it's going to be the partial derivative with respect to y. Yx and y naught is going to be a point that's given, let's say, 1, 2. That's going to be our initial point. Cool? So, like we learned earlier, we're going to partially differentiate this differential equation with respect to x and with respect to y. So we'll start with that. So we got that. So that's our first equation, partial derivative with respect to x. Now we do the same thing with respect to y. Now we're left with two equations right here. We have both of our partial derivatives. Now, what we need to do is we need to plug in that initial condition, and we need to substitute in for the x and the y, and then we're going to find what the slope of a and b equals. So we plug those in. So we have our partial derivative with respect to x right here. This also equals a. We have a solved for. Now we do the same with y. So we have the partial derivative with respect to y. And this also equals b. So now, in this equation, we're looking for this tangent plane. We already have two of these variables accounted for. Four of them, actually. We have a, b, y naught, and x naught. So now, we want to find that z naught. So we go back to our differential equation. We go back, let's say, over here. We plug the variables in. So we find z to equal 13. Now we have our initial equation for the tangent plane, and we have all of our variables accounted for. So if we rewrite a equals 19, b equals 12. Now we'll make some room here. Now we go back to that equation, plug it in. Z minus 13 equals 19 x minus 1 plus 12 y minus 2. Move it across, the 13 across, z equals 13 plus 19 x minus 1 plus 12 times y minus 2. Now this right here is the equation of the plane tangent to this differential equation at the point x equals 1, y equals 2. There you go, Lil Hopital. Go fight that rap battle.
You are now ready, young one. Go, defeat Chaniz Rule, and restore your honor in the calculus world. Go.
Thank you, great Rieman.
Where am I? Wait a minute. I must have to do this calculus problem. Find dz dx given z equals f of x comma y equals y squared plus xy plus x squared. Let's see, what did master dx say? I have to hold the y as a constant in order to get this. So we have dz dx. Y the constant, derivative of a constant is just 0. Derivative of x is 1 times the constant, we get y. And the derivative of x squared is 2x. And there we go. dz dx is y plus 2x. You ignore the 0. Now to find the tangent plane to f of x comma y at 1 comma 2. What was that equation? All right, now let's see what I need to find. Let's get z0 first. I think I just have to plug in these coordinates into the first equation. Plug in 2 for y, you get 4. 1 times 2, xy is 2. 1 squared is 1. 4 plus 2 plus 1 is just 7. All right, good. Now, I need the derivatives. I need both derivatives. So let's find dz, dy also. It's just like the other one, but now the x is held constant. 2y plus x plus 0. And if I want to find it at the point, a is the derivative with respect to x. So a, once you plug in those coordinates, 2 plus 2 is 4. B, plug in the coordinates, 4 plus 1 is 5. And those are just x and y now. I have my equation. Z minus 7 equals 4. X minus 1 plus 5 y minus 2. And I just simplify it out. Z equals 4x minus 4 plus 5y minus 10 plus 7, which was the z naught. For one final simplification, z equals 4x plus 5y minus 4 minus 10 plus 7 gives you a net of minus 7. I solved it. Now let's see if the door will open. It does!
Hey, Chaniz Rule.
Can we do some calculus?
What? Calculus. I'm gonna do some calc with partial derivation. Yup, I learned them all day. I've been solving. This is freaking awesome.
Nah, walking to class like, whoa, that's some hard calc. Gonna need a mathematician with some major swag. I reworked integral and concept like concavity. Even Chaniz Rule be like, damn, you remember to write the plus C. Let's work on intermediate value theme, which is rather easy. First, make sure there's a p between f of a and f of b. You guys must be defined with laws of continuity, and then you have c between a and b, such as f of c equals p. Limits. This stuff is harder than it looks. Thank a calc teacher for all this knowledge. She gave us what we need to go to college. I know that our learning habits are a little bit oddish, but I hope that you can treat us with some tolerance. Now back to the calc, and you know we're going back to attack with the lyrics about arithmetic. But man, that's a whole lot of content. About to go to the calc room and get me some compliments. I be reading calc book and taking it Bernoulli style. He discovered the rule, but I popularized it. Lil Hopital. I make rhymes like I do derivatives. The power rule, man, that stuff is just for kids. Hey, Chaniz Rule, how you feeling now? I think we both know I'm the best calc rapper in this town.
I'm gonna do some calc with partial derivation. Yup, I learned it all day. I've been solving. This is freaking awesome. Said I'm gonna do some calc with partial derivation. Yup, I learned it all day. I've been solving. This is freaking awesome.
What you know about the theorem that I'm named for? What you be knowing about solving lemons with derivatives? Yep, I've been solving all of these problems. I take what they can't solve and find a solution. Think your man is genius for finding all this math stuff. Don't forget his German buddy, the name was Leibniz. I like doing calc 3, I do it just for fun, even though you know I ain't even taking calc 1. Search searching and trying, but I know you're not finding to get the area. Better ask my homeboy Riemann. He'll tell you take f of x to make a rectangle. Then you take some more and add 'em and all. They be like Riemann sums, that's hella tight. I'm like, yo, trapezoids are way easier.
I'm gonna do some calc with partial derivation. Yup, I learned it all day, I've been solving. This is freaking awesome. I do your calculus, partial derivatives, just like the single one, but with a third variable. I do your calculus, partial derivatives, just like the single one, but with a third variable. I'm gonna do some calc with partial derivation. Yup, I learned it all day, I've been solving. This is freaking awesome.
Remember your plus C.